First of all, how many of you are IT people? We got any IT people out there? All right, good. There's a couple friendlies. All right. This is the first time I've ever had IT in my title in my career, actually. I come from an automation background, but they tagged an IT title on me for this job, so I just wonder how many of you were out there. All right. So our agenda for this afternoon, as Dave mentioned, we're going to talk a little bit, walk you through a little bit of a case study here. He was kind enough, I realized I throw a lot of acronyms around sometimes and don't always explain what they were, but he already was kind enough to get them out of the way for me here. We'll be talking about, I use it as MOM, Manufacturing Operations Management, which seems to be the current term most people are using, Manufacturing Execution System being about the same. Plant floor IT systems, basically, that we use to run manufacturing from. So we're going to talk about a journey, basically, a 3-year journey at Johnson Controls to stand up a new process, new technology, new plant, and what we've learned from it from a very high technology perspective with a very complicated set of requirements. And we'll take a look at those lessons learned and then how we're applying those lessons learned and doing things better second time around, and taking those lessons learned and now propagating this knowledge into the rest of our business globally, which is quite a bit bigger than that first plant that we learned. And hopefully we'll have some time at the end for maybe some questions. So Johnson Controls is about a $43 billion company. We touch a lot of different spaces. And we're headquartered in Milwaukee. We operate in many different countries, and we're probably 175,000 employees now. That number just keeps growing by week and week. We're organized in 3 business units. Many people don't probably realize this, but we have one business unit does automotive vehicle interiors. We do entire vehicle interiors for many of the cars you drive, headliners, seating, all the plastic trim pieces. The Building Efficiency Group is a global leader in HVAC systems, keeping us all comfortable. There's a services division that manages complete building management functions. And the Power Solutions Group, which I manage, is the leading supplier of lead-acid car batteries in the world. And we also get now into hybrid electric vehicle battery systems, which we'll be talking about today. And that's the group that I represent. So our Power Solutions Group, 14,000 employees. We're all over the world. 135 million lead-acid batteries produced per year. Like it said, we're the largest supplier of them in the world, and 50 manufacturing sites distributed around the world. A couple interesting things about car batteries I thought I'd throw in. 97% of car batteries in the United States are recycled. A lot of people don't realize that. And there is nothing that even comes close to that. Aluminum cans come in at 55%, papers 45%, and glass is about 26%. And that equates to about 8,000 batteries being recycled every day. So it's pretty incredible. And pretty much we reclaim about 100% out of a car battery. It goes back into service again. So it's kind of a neat success story for sustainability in the environment. Evolution of the battery is an interesting story. Not a lot has changed. We're going to talk today kind of the bottom 2 rows of the battery technology. We're going to kind of tell the story backwards. The story, as we're going to talk about it, is going to start with the lithium-ion technology there towards the bottom right, and we're going to work the story backwards and how we've taken what we learned on the high technology side of the business and worked the systems back up to simpler applications in the traditional lead acid and AGM business lines of our product. So back in 2008, Johnson Controls entered into the lithium-ion electric vehicle business by way of a joint venture partnership. And in 2010, we built a plant in Holland, Michigan. We refer to it as our Meadowbrook plant, with some very generous grant money from the Department of Energy to create green energy jobs, and that was under the American Recovery and Reinvestment Act, and we were given a grant of $299 million, and Johnson Controls matched that for another $299 million. So we have about $600 million invested in this facility in Holland. And it's capable of producing essentially three types of products for our customers. We can produce finished lithium-ion cells. We can produce modules, and we can produce finished battery systems ready for integration right into our customers' vehicles. So it's a process, it's a conversion process. It's basically taking foils, aluminum and copper foils, to create electrodes, and there's a process of dry chemicals converted, mixed with liquids, and coated onto to create electrodes onto the foils. And then they're wound together with separators, basically creating a large capacitor in a similar way most batteries are created. And we wind these together and package them into a can or into a cylinder here, and put terminals on them, and we charge them up. And you get a cell. It measures out at about 3.65 volts. They contain an incredible amount of energy. One of our engineers likens this to, uses the analogy, if you take one of the larger cylindrical cells and you hold that in your hand, you've got enough energy to power a vehicle at 60 miles an hour for a mile with a full loaded, AV entertainment system in the headlights and everything running. So very dense energy package. And so as you start to build this up, we have some customers, like Daimler likes to engineer their own. They like to not give up control of that drivetrain engineering. They like to keep that in their own hands. So they buy the raw cells from us, just like you're buying battery from the store. And they do the rest of the engineering themselves. In other cases, and when you get up into these, you start seeing, how many cells are in these packages here to get to the vehicle performance that you need, depending on if it's a plug-in vehicle or it's a fully electrified vehicle or if it's a hybrid. You start getting up into these, the fully engineered pack here, you're usually upwards of 300 volts. So you got a lot of safety concerns in there. They need to be cooled. There's usually a glycol cooling system on board, and there's all kinds of safety aspects around this. So some customers prefer to do it themselves. Others allow us to do it. There's software on board. So we can sell the raw cells or the modules here. That's typically 12 cells with some supervisory circuit boards on top, maintaining the balance and the charging between the cells so that they have an even life. And then again, the finished pack is a fully contained, it's sealed up in an enclosure. We're actually using them in marine applications now. There's some electrified boats out there that are running these, and there's some commercial vehicles. This was kind of an interesting program being run out of a grant out in California. It's pretty practical when you think about it. The lift trucks that utility companies are using, rather than running the diesel all day long to power the guy up and down on his lift to service the lines, the truck just sits there nice and quiet in the neighborhood, and they use a hybrid battery to power the lift. Kind of a neat program. But these cells are very complex to manufacture. It was a Greenfield process. The equipment is made by only a couple different manufacturers in the world, and there's incredible requirements for the amount of data that we have to capture for our customers from a quality and safety aspect. We have a 10-year warranty on the batteries. Nobody wants to spend this kind of money on a vehicle and have the batteries go out on them. So all kinds of exotic requirements for traceability, genealogy, just like you were making narcotics or pharmaceuticals. So the systems behind this, from an IT perspective, are quite complicated and a lot of requirements. So in 2010, to support this plant that was going up, we embarked on a analysis to try to go out and find some vendors to work with in this space. And we did a traditional Pew analysis. I think there's been other presentations yesterday that I sat through that people talked about this process, and many of you probably been through this, like selecting anything. Pew is a form of analysis. You do a weighted scorecard average. We looked at, you basically go out and you long list some vendors you think in the space. By the way, I'm remiss to mention one of the reasons I'm here speaking today is on behalf of an organization called MESA, the Manufacturing Enterprise Solutions Association, and you'll hear more about this in a few minutes. They're a not-for-profit organization that kind of is a best practice, industry best practices organization. But MESA is an organization where you draw from for information on the field of MES and MOM, and they've got hundreds of white papers and knowledge on this, and we drew heavily from this process. But one of the things they have for member organizations that you can draw from is information on how to go about sourcing vendors for this type of application. Who do you turn to? How do you get that long list? And there's a lot of research information, and we did that when we did this. So we went through a long list, and we got down to a short list of several vendors. You establish your scorecard, and you interview your vendors, and you evaluate them. You make them do some demos. And when we got done with all of this, we ended up choosing a solution from GE Intelligent Platforms, the Prophecy Manufacturing Suite. And I don't believe, GE is a sponsor here today. I know we have GE. GE's in the room here someplace, maybe. There they are. We got GE, and I believe INS, Industrial Network Systems, is here with them. I think is their distributor that's got the tabletop out there with them. So GE was our selected vendor through this process. And one of the reasons they were selected is we were in an extremely condensed time frame for this project, and we needed a partner that could get us all the way through design, installation, commissioning on a turnkey basis. And we needed to have somebody that could accept a great deal of this risk as a partnership that we could hand this over on. And it was a very complicated project, and they did really well for us. So this process, GE was awarded the contract for this in October of 2010. So, July of 2011, the project went live. And it's been a huge success for us, and showing just here examples of some of the functionality that was delivered. I kind of alluded to it based on the requirements that we had defined. Some examples here that we're looking at. This is some of the reporting. This is what we would call a genealogy report, forward and reverse genealogy of every single component lot that's used, from all the raw materials coming into the facility, have a lot number from the vendor, so they're all traceable forwards and backwards, just like you would with food or again with pharmaceuticals. We trace every person or worker that's handled it, every piece of equipment it's been used on, and all of that is traced at every point in the process and verified every time a material moves from one step in the process, every work cell to the next. It's repeatedly tested. And loss of data, you can't really see it too well here, but if you were to see this a little better, there's little red lines between all of that. Those are the links in the genealogy, and we verify at every step in the process those links are intact. If there's a broken link in any place in the genealogy, meaning that we have missing data, that product can't be sold. It has to be scrapped. And that's just a criteria for us. So we do a lot of inventory tracking here around what's a work in process inventory at any given place and time. The process called formation, where the cells are actually converted from inert chemicals or cells into energy storage devices, takes about 20-some days, and it's done in a ASRS, automated storage and retrieval system. And there can be upwards of 15,000 to 20,000 in there at any given time at different steps in the conversion process. And